appears on the title side in order how to automate your node mystery というタイトルも発表になります。皆さんよろしくお願いします。
It's okay. Stay calm. There might have been a murder here, but you're in good hands.
Because that's Detective Tiger.
That's Detective Daphne.
We're here to share with you how to automate your murder mystery.
I'm Tiger Oaks, a software engineer at Microsoft. I'm working on performance work. You can find me on Blue Sky at Not Woods, as in not a certain golfer.
I'm Daphne Oaks. I'm a software engineer at Growth Therapy. I do improv and stand-up on the side for fun. My middle name is Danger, but I swear, I didn't do it.
We live in Seattle, where we host murder mystery parties every year.
So therefore, we're eligible to solve any murder.
What is a murder mystery party? It's a game where you bring your friends together and you become characters in a fictional setting, where you go and gather clues, trade evidence, and solve a murder.
Last year, we held a murder mystery party over and over and over again, 5 times. No, we don't have a problem.
Today, we're going to show you how you can use software to become the ultimate party host.
For our murder mystery, we brought a pre-written kit so we can just focus on the props. We went with this company called Foul Play Games, where we acquired a 1920s steampunk-themed murder mystery, but there are a lot of companies out there.
Then we used our home automation skills to upgrade this paper kit into a techie escape room.
So, mine was down.
And we totally didn't know that was going to happen.
We devised 3 tools to help us solve the murder, all in the last 60 seconds.
We're going to show you how to put together a list of suspects, a dramatic death scene, and a treasure chest filled with evidence.
By the end of the talk, we're going to figure out who committed the murder and who wants to bring down JSConf JP.
First, we'll talk about the suspect list. At a murder mystery party, it can be hard to keep track of who's who. After all, there are dozens of new names to remember, and as players, we can get frustrated by interactions like,
I'm looking for a Julian. Are you Julian? Are you Julian? Do we even have a Julian here?
And I figured out who stole from me. It was whatever your name was.
To help us accuse with confidence, we devised a digital character sheet to address our pain point.
Here's how it works. Players will come in costumes and we'll take photos of them as they come in our place and upload them in the app. Then they'll be automatically prompted and downloaded onto tablets we have set up throughout our apartment.
And this is what the suspect list looks like at JSConf JP. That's right. At this conference, every speaker is a suspect. And I know what you're thinking. Instead of wondering who of them done it, the real question is, how do we implement the web app?
We create the app using 3 tools: Svelte for our UI framework, Convex for our database, and Thumor for machine learning-powered image processing.
We chose Svelte for our layout to achieve this old-timey sepia look. Like other frameworks, Svelte allows us to write reusable components that update when the data changes. But unlike React, Svelte actually has built-in support for bundle CSS and animation. This makes it really easy to implement this type of slide-in animation whenever the picture of our new guest appears. We also wrote a component for our CSS theme, and this makes it really easy to swap out to another theme. So for example, this year, when we held another murder mystery party, we were able to swap it out and make it circus theme, just like that.
We use convex to store guest names and character information. Convex is an all-in-one backend solution that includes support for a database, an image storage bucket, and has real-time sync. So whenever your data changes, it'll automatically send updates to all your clients immediately. You can set up your backend in Convex using simple functions with some built-in validation. And Convex has great TypeScript support, so it'll look at the types of your backend functions and then automatically generate a client API with those same similar types. Convex is a really nice tool to prototype with. I find it much easier to set up for my own projects compared to tools like Postgres or Firebase.
Take a look at this beautiful suspect list again. The pictures are so uniform in terms of their looks and their sizing, and it is not because we're great photographers. Okay. It is not only because we're great photographers. It is because we choose Thumboard, a program that automatically finds faces and crop around them using machine learning. And this is really convenient at a murder mystery party so that we don't have to spend time editing manually, applying filter before uploading them. And you can use Thumboard very easily by making this GET request using an image tag. And there, you can pass in the desired information, such as the size, the filter, and the raw image URL.
To help you create these URLs, I wrote a package called Thumboard.es you can get on NPM. You can call the build Thumboard URL function with whatever options you want, and it'll generate a string matching Thumboard's custom URL format. This also allows you to write your backend using only redirects and URLs. You don't need to deal with any binary blob image processing. If you need to debug somewhere, you can also add meta to the front of the URL and it'll return a JSON API. This JSON also includes coordinates for the face and other focal points. So if you want to do some more manual cropping besides Thumboard's defaults, you can do that using the JSON API.
The Convex and Thumboard can actually be self-hosted, meaning they can run on your local computer instead of on cloud. This is so helpful for us because, for example, we were running the murder mystery at home, but in other cases, we will run it outdoors or even at a convention center. But that being said, you are not limited to using one computer. And that is because all the computers can communicate with one another through the same router, despite the fact that the router is not connected to the wider internet.
Now that we've seen this suspect list, we can now track suspicious things people said, such as...
I've always wanted to be a MC.
You didn't compliment me in my intro. Nice shirt. Wish I had it. Well, if there's no MC, then I don't have to give my talk.
Now that we've seen the motives, it's time to understand what really happened.
At a murder mystery party, the murder is what kickstarted the party. So we need to make sure that the murder is worth investigating. I mean, without any effects, it can look something like,
I'm dead. Find out who did it.
will you all solve this murder? No, right? So therefore, we decide to sprinkle some drama using light and sound effects. Let's now take a look at another murder that's suspiciously similar to the one that just happened.
I'm very pleased to let you know that. Relax. What happened?
It seems that Mai was killed by electrocution. She was wearing a special bracelet that gave her a fatal electric shock. But
Do you know what else is electric?
could it be the computer we programmed those lights and sounds on? In our home, instead of having a single Google Home or Alexa like a regular person, we have one in every single room, 4 in total. Plus, we replaced all the light bulbs in our apartment with smart light bulbs. And we additionally ripped out all the light switches in our home without a license to replace them with smart switches for the ultimate control of every single electronic device.
Don't be scared. Let that resonate with you. We're not the only ones here with a Tony Stark home setup. So just before the murder happened, we gathered everyone in our living room. Suddenly, the lights went out in the farthest corner of the room. The darkness crept towards us, one room at a time, closer and closer, until the entire apartment was dark. And then we heard a zap. Quick, someone turn on the light. There is now a body on the ground.
Spooky, right? But how do these lights work? We control them using an app called Home Assistant, which gives you a universal API to communicate with any smart lights, no matter what brand they come from. We also use a tool called Node.js, which allows you to automate your home using a drag and drop flow. It's also built on top of node.js.
We wrote a program to go through a series of commands. For each room, we have a play a sound and turn off the light and wait a second before repeating in the next room. And it continued until all the lights were turned off in our apartment. And after a dramatic 3-second wait, we played a zap sound. Our use case was so simple that we did not have to write any code. But if you want any more complex logic, you can also use Node.js for the same thing, and it can support if statements, filter, or even your own custom JavaScript functions.
I'm getting a police report. They discovered a treasure chest that belongs to one of the suspects.
We need to figure out what's inside.
But to do that, we need to understand how it works.
In the story that we bought, it mentioned this locked chest that belonged to a professor, containing his last greatest secrets. But instead of it being physically locked away, the instructions in the story said, a guest will just walk towards you, make a guess, and if it's correct, you just hand over a piece of paper. That's pretty boring. We can do better.
Instead, we decided to take inspiration from escape rooms and create our own physical safe in our home. We bought an old used trunk off of Craigslist and then installed a magnetic lock inside of it. Then, this is the moment the real safe got opened at our party. Much more exciting, this became a moment that our guests talked about for months after the party.
Before this project, we actually had zero experience creating our own hardware. But we found out just how simple it was. There was no soldering involved, and there are only 3 components you should be aware of. We have the magnet that holds the lid shut, we have the switch that toggles the magnet circuit on and off, and we have the server that controls the switch programmatically. And these 3 components make up what's known as the electromagnet circuit. Let's now dive into the magnet.
So the magnet is composed of 2 pieces. There is the metal plate, which you attach onto the lid of the treasure chest, and an electromagnet piece that you attach onto the base. The electromagnet can be turned on and off with electricity. When it's turned on, it'll hold the metal plate tight, making it so you cannot open the chest.
Let's take a look at this diagram. In this circuit, the left is the electromagnet, the middle is the switch, and the right is the power supply. You can think of the circuit as one big circle that can be severed when the switch is off in the middle. But when the switch is on, that's when the currents can flow through, and now this electromagnet can emit magnetic field. In your home, a switch is something that you can just flip on and off using your index finger or your middle finger if you're not having a good day. But in our circuit, the equivalent to that is something programmable known as a relay.
The relay is something that you can insert instead of a light switch in the middle of your circuit. You'll plug wires into ports on the bottom labeled NO and COM. And then you also have a third wire called a signal wire you plug into the top in a port that's usually labeled S or in. When this wire is turned on, it'll activate the relay, and when the wire is turned off, it'll close the relay. But the relay itself is basically just the same as a light switch. It does the exact same thing. The signal wire just becomes an automated finger that you can use to toggle it on and off.
Let's now talk about how to control the relay using a server. And we do that by connecting the relay to a Raspberry Pi. A Raspberry Pi is essentially a simple computer that runs on Ubuntu and has a series of ports to plug wires into. So here we plug the blue signal wire into an arbitrary port on the Raspberry Pi. And then we're going to plug a red wire to a positive pin and a yellow wire to the negative pin. And it doesn't really matter what colors you choose, because at the end of the day, these are just strips of wire and metal that are wrapped by insulation. But I highly recommend for you to use the same color if you're into the good puzzle. Let's now talk about the Raspberry Pi pins. These pins do various different things. We have a group of pins that supply the power, and we have another group of pins that are the ground. And the last group is the GPIO, or the general purpose input-output pins. And these ones are the ones we're going to program.
We happen to choose the pin labeled GPIO 18, so we can control it using that same ID in software. We'll use the on-off library from NPM to get an interface to read and write to the pin, which will control the magnet. Writing 1 will turn the pin on, writing 0 will turn the pin off. Then, we can connect this to an HTTP server. We'll create a server such that whenever we receive a post request, we will check the current state of the pin and then toggle it to be the opposite state. We'll also handle a GET request where we return the current state of the pin. Now, whenever we send a post request to the Raspberry Pi, it will toggle that pin from on to off, which will turn off the signal wire, which will turn off the relay, which severs the electromagnet circuit, finally turning off the magnet and unlocking the chest.
That's right. Now let's go back to the diagram as a whole. Now it is made of two circles. The bottom circle is between the electromagnet and the power supply. And the top circle is between the Raspberry Pi and the relay. Congrats, you just learned everything you need to know about the circuit.
For entering the password, we put together an HTML and CSS app and then loaded it on an old banana phone.
Because bananas are funny.
But really, you could put this on any old browser or any old device that runs a web browser because it doesn't need any client-side JavaScript. You could use
a phone,
an old laptop,
a TV,
smart fridge if you want.
Fine, you win.
We'll put together some HTML with a single input that takes a 4-character code. Since we're using the built-in form element, this will automatically handle enter and submit, and then just send a post request to a server once that code has been entered. In Swapkit, we can set it up so that we render this template by first sending a GET request to the Raspberry Pi to check if the chest is locked or not. And we'll also use the CSR option to tell Swapkit not to send any client-side JavaScript. Then, whenever we receive a post request, we'll check the code that was submitted in the form data, see if it matches the expected password, and if so, send a post request to the Raspberry Pi to unlock the chest.
Now that you understand how it works, let's find out what's inside of this treasure chest.
It's open. Oh. Inside.
That means
The murderer,
it's only
Mariko Kozaka,
who has escaped because she is so guilty.
that she already went to give her number to her next talk.
Mariko has been so jealous of the shirt that Mai is wearing that she committed the murder.
I had it. You know what would go well with the shirt? It's bracelet.
We've solved the case, and that brings us to our conclusion of our talk.
If there's any takeaway for the presentation, is for you to host a murder mystery party and invite us. But the real takeaway here is that anyone can work on home automation projects.
We came into this project with not a lot of hardware experience, but it turns out that a lot of it is just plugging wires, following instructions. And for the software side, you already know what to do. You're JavaScript developers.
And lastly, we want to stress how creative software can be.
In our day-to-day, a lot of our side projects might end up being developer tools or simple apps, but you can make some really creative applications.
For us, Tiger and I love being involved with theater. We love doing improv, stand-up, sketches, and all that. So we found a way to integrate theater with software. And the result of that is us adding showmanship to our murder mystery parties.
Thank you for listening. You can find us at tigeroaks.com and daphneoaks.com. And if you want to get the slides for this talk, you can go to my website, or I'm also going to be posting a blog soon that dives a little bit deeper into the hardware.
Again, that's Tiger Oaks.
She's Daphne Oaks.
Okay.